Alright, how's it going? This is the next one. This is rational functions. What I'm going to target is I can graph rational functions. I can transform them by changing parameters. So this one's all about graphing the quotients that we've been working with. So a rational function is a function whose rule can be written as a ratio of two polynomials. The parent rational function is f of x equals 1 over x. Its graph is a hyperbola, which has two different branches. Not all rational functions are hyperbolas. This would happen when you have those holes. Remember when we had like x plus 5 over x plus 5? They canceled each other out, and then x can't equal negative 5. You have a hole in that graph right there. That would be x plus 5 over x plus 5 is actually just 1, so that would be a constant graph, but you'd have a hole in the graph at x equals negative 5. It's not a hyperbola in that case. It is a hyperbola if we have an asymptote. Okay, that's when you have something that doesn't cancel out on the base. This is asymptotic in nature. We're going to have an asymptote at here at x equals 0. Why? Because x can't equal 0. Okay, so our key points for these graphs are going to be negative 1, and 1, 1. I'm going to graph those here, just like that. Okay, so let's examine what happens here. For very large, I'm going to make a table. I'm going to say x equals negative 5. If x is negative 5, 1 over negative 5 is 1 over negative 5, or about, well, it's equal to negative 0.2. So let me go ahead and graph that on the graph here. 1, 2, 3, 4, 5. Right there. Let's make x equal to negative 1 over 5. If x is negative 1/5, 1 over 1/5 is going to be negative 5. So we have that spot right there. Let x equal 1/5. 1 over 1/5 is 5. Here. Let x equal 5. 1 over 5 is 0.2. There. Connect the dots, you have a hyperbola with an asymptote at x equals 0. What does the asymptote mean? Well, for smaller and smaller values of x, so if I plug in 1 over 1,000, for example, the y value blows up really big. Okay, I'm sorry, 1 over 1,000. So 1 over 0.0001 would give you 1,000. So if I'm really close here, really close to the y-axis, then my y value is going to be very big. In fact, the closer you get, the bigger they get until you get to infinity. Well, you're not ever going to get there, it's a concept. So it blows up to infinity at x equals 0. And on the other side of 0, it's going down to negative infinity. Also notice here that we have another asymptote at y equals 0. Okay, so we're never going to get to 0. You can plug in an infinitely large number for x, 1 over 100,000. Your y value is going to be a very, 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 very small number, but it won't be 0. So we're never going to get to 0. So we have two asymptotes on this graph, the y-axis and the x-axis. This is called a hyperbola. Alright, so moving on, we have our basic transformation stuff here. A over x minus h plus k. Using the graph of 1 over x as a guide, describe the transformation and graph each function. So I have g of x is equal to 1 over x plus 2. What's happening to our x's? Think back to every other transformation we've ever done here. When it's affecting the x, think of this like a parenthesis right here. Okay, so this isn't the argument. If it's x plus 2, think opposite. So this graph is actually moving to the left. Well, that looks like the right, so it's going to the left. Okay, so this moves to the left 2 spaces, and that's the only transformation there. We'll use our parent points here, -1, -1, and 1, 1. So I'm just going to subtract 2 from the x values. -3, -1, and -1, 1. I'll go ahead and graph those. -3, -1 is here. -1, 1 is here. And throw down your graph, keeping in mind that since we've moved the graph to the left 2, we're moving everything as well to the left too, so we're also moving that asymptote to the left. So we have an asymptote at x equals -2. Alright, next one. This one is the k value is being affected, so it's going to be a shift downwards, so we're moving down 3 units. We also have an asymptote at, I forgot about one, y equals 0. There's a horizontal asymptote here as well. Alright, next one. We're shifting down 3. So let's look at our parent points here. This is affecting the y values. It's shifting downwards, so I'm going to subtract 3 from the y values. So our new points are going to be -1, -4, and 1, -2. And go ahead and graph. Okay, so the only thing that's changed here, I still have an asymptote at x equals 0, because I didn't move to the left or right at all. I just went down. So we have a new asymptote at y equals -3. It's down here. This is our new asymptote. Alright, go ahead and turn the page. What's going on here? This is a move to the left 4. So we're going left 4. So normally I would have the graph here. We're just moving to the left 4. 1, 2, 3, 4. So our graph, this is just a really rough sketch here. We move to the left 4. We have an asymptote at x equals -4, y equals 0. This is a shift upwards 1. So we have our graph like before. We just moved, let's see, where would this be here? Oh, missed it. Right there. So we just shifted upwards. So you have the asymptotes right down the center here at x equals 0, and then the new one would be asymptote at y equals 1. Alright, let's look at rational functions. Okay. So just looking at this, this would be a continuous function. It's continuous because it has no gaps or breaks, meaning it just moves on and on and on and on and on, and the domain fills out, the graph fills out the domain. In other words, you can, any x value plug into that graph is going to work. A discontinuous function will have a gap or break, meaning you have those domain restrictions like we did before. Say x can't equal 3. This would be discontinuous at the spot x equals 3. Say you have a asymptote at x equals -4. Your graph would be discontinuous at x equals -4. Alright, so The values of h and k affect the locations of the asymptotes, the domain, and the range of rational functions whose graphs are hyperbolas. Why was the math book sad? Because it had so many problems. Ha ha ha. Always label your axes. Ha ha ha. Alright, moving on. Identify the asymptotes, domain, and range of the function of the following, then graph it. So this is going to be 1 over x plus 3 minus 2. I don't know if you guys have noticed before, if we move to the left or right, that shifted our vertical asymptote to the left or right, and if we moved up or down, that shifted a horizontal asymptote. The original function, 1 over x, has asymptotes at x equals 0 and y equals 0, so on the two axes. This graph, we're moving to the left 3, and we're moving down 2. So our new asymptotes are going to be at x equals negative 3, because we're moving to the left 3, and y equals negative 2, because we're moving down 2. So the domain, let me graph it first. Okay, so I'm just going to, my original graph, let's use our points here, because I don't want to get messed up. The x value, you're subtracting 3, the y value, you're subtracting 2. So negative 1 minus 3 is negative 4. Negative 1 minus 2 is negative 3. That's our new spot. 1 minus 3 is negative 2. 1 minus negative 2 is negative 1. That's our new spot there. So let's graph these spots. Negative 4, negative 3 is here. Negative 2, negative 1 is here. And this is our new center. The new center should be at negative 3, negative 2. So if you can think of that as the spot that's kind of in the middle of the two asymptotes. Okay, so here's our new graph. So it says identify domain and range. Domain is all x values, remember. So we can say all real numbers with an exception that x can't equal our vertical asymptote, negative 3. The range is going to also be all real numbers with the exception that y can't equal the new asymptote, y equals negative 2. Alright, so this one, looking at it real quick here, I'm not going to graph it. We're shifting to the right 3. So we're going to the right 3, and we're going down negative 5. So our new our new vertical asymptote is going to be at x equals 3. The new horizontal asymptote will be at y equals negative 5. Okay, so if you have an asymptote at x equals 3 and an asymptote at y equals negative 5, think of this line here is splitting up your range. Your range is up or down. So the range is going to be all real numbers, but y can't equal negative 5. And then think of this line right here is splitting up your domain. So think of it like, here's your graph, it hits this spot, and then it has to jump. It's discontinuous at that spot. So our domain is all real numbers, but x can't equal 3. Alright? So let's go ahead and move down here. I'm going to pause the video. I'll see you guys soon.